So you should already know how to solve definite integrals and solve integrals using substitution. And there's something that you can do when you combine them that makes life a little bit easier and quicker in not all cases. So let's use this as an example. The definite integral from 2 to 3 of x over x squared minus 1 dx. First, let's integrate x over x squared plus 1. And you should see what we can do is use u sub u equals x squared minus 1 du equals 2x dx. And then we substitute that into the integral, which is 1/2 1 over u dx. I think that should be right, yeah. And now we integrate this, so 1 over 2 ln of u. And instead of plugging back x squared minus 1 into u and then doing the 2 and 3, what we can do is just keep the u in there and then change our bounds, because these bounds are for when our variable is x, so we need to change our bounds to when it's u. So if u equals x squared plus 1, then when x is 2, u is going to be u equals 2 squared minus 1, which is 4 minus 1, which is 3. And when x is 3, u equals 3 squared minus 1, which is 8. So we've changed the bounds from 2 to 3 to 3 to 8 because our variable has changed from x to u. We need to do that. So now it's just pretty easy. 1/2 ln 8 minus 1/2 ln 3. And then we can simplify that to 1/2 ln 8 over 3. And that's our final answer. And let's do another example. This one is the definite integral from 0 to 1 of x squared times e to the x cubed plus 1 dx. Now first, we need to integrate this part, and you should see that we can use u substitution by setting u equal to x cubed plus 1. That means du will be 3x squared dx. And now our integral is the integral of 1/3 e to the u du. And now we just integrate this and we get 1/3 e to the u. And instead of plugging back x cubed plus 1 into u, we need to change the bounds from 0 to 1 to something else. So when x is 0, u equals 0 squared u cubed plus 1, which is 1. And when x is 1, u equals 1 cubed plus 1, which is 2. And now we plug these back in to 1/3 e to the u, and we get 1/3 e squared minus 1/3 e. And that's our final answer. Now, let's get into some practice problems. If you think you know how to do this one, pause the video and try it. This one says to evaluate the definite integral from 1 to 2 of ln x over x dx. And first we need to u sub, and you can notice that we can separate this from ln x over x to 1x times ln x, and then the u sub is pretty obvious there. It's just u equals ln x, and then du equals 1 over x dx. So our integral turns into the integral of u du. Pretty simple. And then when we integrate that, we get u squared over 2. And to set our bounds, we need to find u when x is 1 and 2. So when x is 1, u is ln of 1, which is 0. And when x is 2, u is ln 2. So ln 2. So that's just ln 2 squared, ln 2 squared over 2 minus 0. And that's our final answer. Now, let's do another practice problem. If you think you know how to do this one, pause the video and try it. This one says evaluate the definite integral from 0 to pi over 4 of tan x dx. And as always, we need to integrate this part. So to integrate tan x is just sine x over cosine x. And we can set u equal to cosine x, which means du equals negative sine x dx, which means our integral is just negative the integral of 1 over u du. And this turns into negative ln of the absolute value of u. And now we need to set our bounds. So when x equals 0, u equals cosine 0, which is 1. And when x equals pi over 4, u equals cosine of pi over 4, which is square root of 2 over 2. And now we do this, which is ln of square root of 2 over 2 minus negative ln of 1, which is plus ln 1, which is just 0. So our answer is just this, negative ln of square root of 2 over 2. Now, let's do one last practice problem. If you think you know how to do some, then pause the video and try it. This one has to evaluate the definite integral from 0 to 1 of 1 minus 3 times x squared over 1 minus x cubed plus x dx. And the u sub for this one will just be u equals 1 minus x cubed plus x, and du is conveniently the numerator, dx. And our integral will just be the integral of 1 over u du, which is just ln of the absolute value of u. And to find our bounds, as always, we plug in the lower bound into x for u, which is 1 minus 0 plus 0, which is 1. And the upper bound is 1 minus 1 plus 1, which is also 1. So this, whenever you have the bounds that are the same, the answer is just going to be 0, because you find one thing and you subtract the same thing from that. So your answer is going to be 0. That's the final answer. So everything that I explained in this video, and all the problems that I went through, should teach you everything you need to know to solve definite integrals using u substitution. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.